Scott and Dave Schenkel, and we're doing a group project for school. We're SCC students in the environmental science program. This is our second year and we're studying water resources, and we're doing instructional video on Wolman Pebble count and embeddedness. We'll be doing this video out in the field at Liberty Creek, just east of Spokane, and Hangman Creek, where we started.
We will be instructing you on procedures to properly execute a Wolman Pebble count. Our members here are Matt Helm, Dave Schenkel, and Scott Bacon. The first thing you want to do is make sure that you have all the necessary tools to accomplish the task. First of all, you'll need a pair of waders. Second of all, you'll need a life jacket. For safety, you always have one on you. And you will need a note taker with a pebble count measurement guide. Particles are tallied by using classes or categories. We'll explain this later in the video.
We changed our spot from Lower Hangman Creek to Liberty Creek. The substrate was too far below the water level to do a pebble count. So here we are at Liberty Creek. Dave is going to establish bank full on this side, and then he will establish bank full on that side. This is the transect we have chosen, and we found it on our map, and we will indicate it on our report. Now we've chosen our transect, and now we're going to describe how we're going to go about measuring. We'll start here working downstream side, and then we're going to zigzag down upstream and measure our rocks until we have 100 samples to get our representative count.
What I'm showing now is how to determine your size classes. First you got to have some kind of a measuring device that has the millimeters measured out up for you, and after you do your heel-toe step, which will demonstrate in a little while, you pick up your rock. This would be the three axes that you have. Is your long axis, you have your short axis, and you have your intermediate axis. And your intermediate axis is the axis that you want to measure. That will measure it out to 35 millimeters. Move on to the next one.
We're demonstrating here now is a Wolman Pebble count. We're starting at bank full. He's going to reach down, pick up whatever he feels, and it looks like he's going to have sand and silt. One more toe. He's going to pick up the first rock he finds, which is sand and silt again. Looks like he might get some rock here. And he's on his first rock. He's measuring the intermediate length of the rock. And he continues on. Matt is taking down the measurements and putting them in a logbook. We continue this step by step all the way across the transect. As soon as we get to this side, we'll zigzag upstream. After we've gone through the entire cross section, we moved on up, coming up to bank full, sand and silt, and our first transect is complete. After Dave got done with the last two transects, we're going to continue on upstream in a zigzag pattern until we get a representative count.
I'm Matt, and we're out at the Spokane River, just north of the school. I'm going to talk to you guys about embeddedness. So the definition is it's the degree to which fine sediments surround coarse substrates on the surface of a stream bed is referred as embeddedness. Although the term and its measurement were initially developed to address habitat space for juvenile steelhead trout, embeddedness measures have been used to access fish spawning and macroinvertebrate habitat, as well as substrate mobility. Embeddedness is used as a water quality indicator in some areas.
The significance of embeddedness is the character of stream substrates is important to both physical and biological stream functions. Physically, as stream substrate becomes more embedded, the interstitial space between particles is reduced, thus effectively reducing streambed roughness and altering channel bed form and hydraulics. Streambed and substrate mobility can be substantially affected by the quantity and characteristics of the fine material.